Okay, in this video we're going to talk about solubility, how to determine whether or not something will dissolve. Okay. The problem is that some things dissolve better than others. The idea is that most things do not dissolve. Okay. And this is super useful. This is why when it rains, the mountains don't disappear because they got wet. Basically, it's nice that some things don't dissolve. It's nice that most things don't dissolve. But there is a set of rules, just through trial and error, that people have figured out to be able to predict what will dissolve and what won't. So unfortunately, I'm going to ask you to memorize the solubility rules. Okay. So these are known as the solubility rules. I guess I probably should define, if something dissolves, it is said to be soluble. If it doesn't dissolve, it's said to be insoluble. Okay, so essentially this is divided by different types of ions, and we want to be able to just look at the formula of a molecule and decide how well it's going to dissolve. So here's the list of solubility rules. Okay, anything that has nitrate as the anion is always soluble. So if it's iron nitrate or sodium nitrate or whatever, it will dissolve. Okay, in other words, if you threw it in water, it would be aqueous. Okay, things like acetates are always soluble. So you remember all those polyatomic ions that I said never go away? Here they are again. I still need you to know the charges. I need to know the formulas. Okay. Ammonium compounds are always soluble. Okay. Honestly, any compound with a cation that has a column 1A, column 1A metals. So this would be lithium, sodium, potassium, rubidium, and cesium. Technically francium is in that column, but it's radioactive, so we're not going to worry about that one. These ones are always soluble. You'll notice that these things all tend to have like plus and minus 1 charges. Things with low charges tend to be easier to rip apart. The larger the charge, the harder it is to force them apart. Okay. So these ones are the always. There's a few that are a little more nitpicky. The halogens, so like chlorine, bromine, chloride, bromide, and iodide are usually soluble, but there are some exceptions. Okay. And the exceptions are lead, silver, and mercury. Okay, oh, actually that's mercury plus 1. Okay, so if you had something like iron bromide, that would dissolve, but if you have lead bromide, it will not dissolve. It'll be a solid. It will not become aqueous. Okay. Sulfates are the only one on the list that has a -2 charge. Sulfates are usually soluble. We'll learn later that it's because they have resonance structures, but we haven't learned what that is yet, so don't worry about it. And the exceptions for this, except with lead, strontium, barium, and mercury. Okay, so you'll note this is not like every ion ever. Okay, so what happens if we encounter something that isn't listed? The general rule of thumb is, because most compounds don't dissolve, if a compound is made of ions not listed, it is assumed to be insoluble. In other words, it'll be a solid. It will not dissolve. Okay. So let's try a couple examples and kind of see how this works. Okay. So let's say we've got something like sodium carbonate. Essentially what this set of rules, I guess I just put it up, but this set of rules, if something is soluble, it'll be aqueous. If it is insoluble, it will be a solid. So what we want to know is if you throw it in water, do we write it as aqueous or solid? So if you look at the list, we don't know anything about CO3, but we do see that sodium is in a column 1A, and it says it's always aqueous or always soluble. So this would be aqueous if you dissolved it. If you threw this in water, it would dissolve. Okay. How about something like ammonium phosphate? Okay. NH4 is one of the ones that we can predict is always. We don't know anything about phosphate, but it doesn't matter because this one's aqueous. Okay. How about something like silver bromide? Silver 1 bromide. Okay. Silver we don't know much about. Bromine is usually aqueous, but silver is one of the exceptions. So if you look at this list, bromine would be soluble except with silver. So because silver is the exception to this thing would not dissolve. It would form a solid, or it would stay solid. It wouldn't dissolve at all. Okay. How about something like NiOH2? Okay. If we look through the list, nickel is not anywhere listed, and OH is not anywhere listed, so we have to go by this bottom thing. If a compound is made of ions not listed, it's assumed to be insoluble, so it would be a solid. Okay. The idea is, if you can memorize this list, which I will need you to memorize, I guess I'll write this on the side here. Memorize. The idea is if you see a compound, you'll know whether or not it will dissolve easily. Okay? All right, thanks.